Hey guys, it looks like we're live. Welcome to FringeFM, the Tech Talks edition, where I, yours truly, get on the podcast and discuss up and coming exponential technologies, where they're headed, and how they're going to impact all of our lives. I'm pretty pumped about today's episode. Today, we're talking about biotech and genetic engineering. This is something that's near and dear to my heart and something that I think is ridiculous in the ability for it to change all of our lives. Just think about it. We've programmed computers. We've changed the core genetic or the core computational code of what computers can be and gone from mainframes to iPhones to AirPods to all of this incredibleness. And we haven't done jack shit when it comes to our own biology yet. Today, we're advancing into a world where we can explore that biotechnical revolution, so to speak. We can start to compute and change the way that we as humanity, society, and everything else around us, from what we eat to how we live, functions. So today we're talking about biotech. I want to do a quick overview of why this is such an interesting topic and why we're talking about it today. So a lot of you may have heard of CRISPR. Casper's a great ghost. You may have heard of CRISPR-Cas9. It's something that was invented in actually two different universities almost simultaneously. They're fighting it out. I believe one of the universities is one now, but it's essentially a program to edit the genetic code of all of us. We're made up of DNA. We're made up of tiny little cells, which has this strange code which determines not necessarily everything about us, but a large degree. I'm going to be male. I'm going to be tall. I'm going to have an obnoxiously long beard. I might forget to shave that beard. All of those things are, in essence, either written into or impacted by, in some way, our DNA. Well, now what they've created is essentially a word processor where, why type this? Let's change these genetic codes a little bit and insert something here. Let's make a cut, and use these different essentially Cas9 it's a protein which researchers accidentally found out allows you to edit genetic code. So there's been a ton of advancement here. This advancement has been propagated and really interesting because of the drop in the genome sequencing price. So it used to cost a fortune to sequence the human genome. The Human Genome Project, it took 23 years, $2.7 billion for the first human genome, i.e. genetic maps, to be created. Now today you can do it for $1,000 and it takes a couple of days, maybe a week. You get all of your genetic information, the same thing that costs $2 billion, and it's exponentially improving. This is like 23andMe, things of that nature that are becoming more and more ubiquitous and more something that people are doing when they want to keep track of or improve their health. The big reason why this has been so possible, not just with the reduction in costs, but also with the increased power of compute, i.e. AI. When we have massive data sets, when we're able to take this genetic data, correlate this with other people, and look at what the implications are. If we have these genetic traits, these genetic mutations, etc., on certain aspects of their DNA, we're able to see this is where problems come in, or this seems to lead to better longevity. All of those are really interesting, really exciting, and with the ability to understand and the ability to manipulate, it becomes really tempting. The last really interesting thing, at least in our overview part of biotech and where we are when it comes to genetic editing, is what's called a gene drive. A gene drive is a technology where your mom and your dad made you. You got exactly half your DNA from your mom, half from your dad. Turns out you got all of your mitochondria from your mom, which is actually a really big deal, but we're not going to dive into that right now. So you get half from each. That's typically how evolution works. That's how sexual reproduction works, unless you're an asexual species. What a gene drive is, however, is this changes the way that genetic expression happens moving forward. Let's say I created a gene drive, and the gene drive was something where I created my own personal DNA. It's like a copy paste. How a gene drive works is if I go and have babies with another woman, they're going to get my DNA, or they're going to get whatever these changes are. A gene drive forces specific genetic changes and specific genetic properties on every single one of the offspring. This is something that has really interesting applications. Okay, let's do it. Let's talk implications in exciting areas. So one of the really interesting, exciting areas of gene drives is curing malaria. Malaria happens from one specific type of mosquito that carries malaria mutations and is able to pass on these diseases. Well, people are looking now at using gene drives to wipe out these mosquitoes. well, what happens now? The males can't really make babies, and they all end up dying off. And they've seen this in experiments over and over in the lab, where you'll introduce these genetic changes, and suddenly you'll come back a week or two later, and every one of the mosquitoes is dead, or every one of the mosquitoes is red, or all of these mosquitoes are glowing in the dark. There's some really, really interesting stuff. And I think with genetic engineering especially, our reach exceeds our grasp. We can do more than we can understand at this point, which is really interesting, but it's also really exciting. It's really dangerous as well. We'll talk about that a little bit more. But the big applications right now of CRISPR and the concept of genetic editing is fighting disease. There's some really big diseases right now. Of the 9 out of the 10 top ways to die right now, according to the World Health Organization: heart disease, pulmonary disease, Alzheimer's. There's a bunch on there. 9 out of 10 are due to health issues, diseases, either chronic or onset. The only other one is road deaths. So you get hit by a car, and we're dealing with that right now with self-driving. But there's 29 million deaths per year that are health related, specifically to either short-term or long-term diseases. And these are the type of things where, as we understand how this happens and why it happens, if we can increase people's ability to recover from cellular damage, we can decrease the chance of having obesity, having heart disease, having all of these things, which are, by the way, we'll dive into those in another episode on what causes some of these massively challenging, what essentially fucks up people and causes them to die. We'll talk about those on some other episodes, but in terms of fixing these problems once we have them, there's 2 routes. There's the nutritional, and then there's the genetic. So if we're able to make these human genome type edits on a personal or a societal basis, it creates some really, really interesting and exciting things. Specifically because right now if you want to live longer, what's the best way to live longer? Just to not die. If it turns out, so the average male life expectancy worldwide, 70.5 years. Female, 72.8. So women live a little bit longer than men. Congratulations. But it's still, it's 70 years, roughly, give or take. There's a huge variance if you look between different countries. But at the same time, it's still not that enormous. But think about the last 5 or 10 people that you know that have died, or whatever that number is. What percentage of them died from old age? I'm going to bet money that the old age percentage is very small. They're all getting wiped out by some disease of some kind. It's Alzheimer's, it's Parkinson's, it's dementia, it's maybe they got hit by a car, but that doesn't count for this one. But just in general, old age is not really getting us very much because we have other things getting us first. So if we can decrease the disease ratio or increase the quality of life via specific genetic edits, maybe we make ourselves slightly stronger, or we have our bones and muscles stay stronger longer, or for men, we keep testosterone production moving. If you want to feel like you're 20 for your entire life, as opposed to feeling like you're 90 and the doctor tells you, don't worry, this is normal based off of your age range. Well, you know what? No one gives a shit what's normal based off of being a 90-year-old. They want to feel good for their entire fucking life. So what the hell is the point of looking at ranges as opposed to trying to optimize things? And that's really what's happening here, is human optimization. And that optimization will lead to both longevity and health, or quality of life improvement. So this is really, really exciting for me. Another area which we've talked about before, and by the way, if you haven't checked it out yet, go to fringe.fm or fringe.fm/YouTube, and you can check out our roundtable where we talk a bit more about some of these technologies in the biotech, longevity, and clean meat space. And the last one I was talking about is clean meat. I'm incredibly excited about this. If you haven't checked out our video, make sure you subscribe to our YouTube channel, fringe.fm/YouTube. If you're not checking it out now, hit subscribe, and then look for our clean meat video where we break down the science of lab-grown meat. It's really exciting in terms of reducing pollution, better health, happier planets, and not having to murder billions of animals every fucking year. Humanity eats 700 billion pounds of meat a year. That's a lot of meat. That's a lot of suffering. We can do much, much better in the biotech, synthetic biology type movements that's going on, where we can understand what's happening, computationally control some of this with computers and other systems, and then be able to create better forms and more successful forms of life. Really, really interesting. In terms of these fields, there's a ton of pros. So we all want to live longer. People have wanted to live longer since forever. Emperors in China used to drink poisonous serums, etc., because they thought that would reduce the weakness in them and make them live longer. It didn't entirely work, but at the same time, you can kind of see the point. Even the most powerful among us want to live longer. Even Trump has a toupee to look younger. We all want to look younger as well, and it turns out that biotech can also do that. We're transforming the world through software, and soon, very, very soon, i.e. starting now and exponentially increasing from here, we're transforming the world through the software of life, DNA. and programming that. Extending life, reducing suffering. We've talked about that quite a bit. When we live longer, there's a couple of major implications. So people are most productive, most successful, most intelligent, typically in their 40s and 50s. They've gone through and they've learned what life has to teach them, and they're able to contribute the most as much as they will ever contribute. They're earning the most that they possibly can. But this is also the kind of time when either they want to slow down or their body starts to break down. If they start to slow down, their body almost always starts to break down. But if we're able to have people living longer at this high functioning level, if my brain's 1%, 5%, 10% better, I'm going to be way more productive. I'm going to be way more creative. I'm going to be doing so much more for society as a whole that there's major, major implications for the economic and societal shifts that will happen as people start to live longer and as people start to self-enhance. So I mean, just think about it. What would have happened if, I mean, we'll even look at music. How many of these musicians, there's the 28 Club or the 27 Club or whatever, they all are overdosing on music. Imagine how much, on drugs, imagine how much incredible music we would have if they all didn't kill themselves. Well, that's a very similar concept, but applied not to people overdosing, but to people just dying out due to weakness, mental problems, etc. It's really interesting. Biotech. With the growth of AI, this is specifically driven by both cloud compute and GPUs. So GPUs typically used for video games, Xbox, computer graphics, etc. They've also been used now more for cryptocurrency mining and AI applications. But by being able to have more computing power, we're able to throw this computing power at all of this genetic information that we're able to take in, both from a DNA, epigenetic, RNA, microbiome type perspective, and optimize what it means to be human. If you're able to optimize what it means to be human, eventually you become superhuman, because if you're comparing to everyone else, which it's not something that's good, comparing yourself to others is typically not a very valuable way to go about living life. But if you are comparing yourself to others, you're going to be outperforming everyone else because you have more information, more control, and realistically, genetic engineering is going to become very common. So as you're able to make slight changes to increase intelligence, increase longevity, increase strength, increase sexual performance, make yourself look better, etc., people will want to do it, A, for their kids, and B, for themselves. First, it will probably happen with kids because it's much easier to do in vitro than it is to change an existing organism. The existing organism may have trouble, but as you're growing, you can grow into those changes much more easily. But either way, this is something where it's going to be really expensive coming out. So we jump into the cons. So if this is something where the rich can afford it and the poor can't, who gets access? Well, the rich get access. Well, who gets smarter? Well, the rich get smarter. Well, if you're smarter, who makes more money? The rich make more money, but they're already rich. And we kind of get into a flywheel of evolution, which is rapidly increasing, because if I have an IQ of 200 and you have an IQ of 80, there's probably not going to be a huge opportunity for us to, become partners and have a baby together, because I won't find you interesting. And then as an IQ of 300 and 200, or if I'm going to live to be 200 and you're going to live to like 75, I don't want to have to go through the heartache. And you kind of create a scenario where your circle of potential mates gets smaller and smaller and smaller for people that are at that highest level. I mean, look at celebrities. They can only date celebrities, because otherwise what would the magazines say? Well, it's the same thing here, but instead of that, they can only date super people, because otherwise their kids are going to suffer from the genetics of someone else, so to speak. So I foresee us getting into a situation where, because there's so much money that will initially, it'll be expensive initially to get a lot of these genetic edits, especially just considering how much research still needs to go into which genes we need to turn on and off in people. But as that comes along, rich will inevitably, there'll be a black market. Well, it doesn't really matter. Technology typically finds a way, especially when there's massive, massive upside, and there's really massive upside here. So as that happens, costs will start to come down, but will they come down fast enough to catch up for the accelerated velocity of other individuals, specifically rich, elite, etc., of their growth and evolution as a species? I'm not positive on that, so that's a major con that I see. Another major con of the genetic engineering type movement is what I said before. Our grasp exceeds our reach exceeds our grasp. Humanity's able to do things now that can completely wipe us out. This is one of the solutions to the Fermi paradox. Possibly other aliens had similar type technologies, biotech, etc., and were able to kill themselves because they thought they knew better and turned out that they didn't. It's kind of like a guess and check in some ways. And when it comes to a situation like that, it's always good to be careful, but at the same time, in a world of conflicting countries where having a advantage over another country, for instance, I mean, look at the US, look at Russia, look at what companies done specifically during the Cold War. They were doing anything possible to get an advantage. Well, if you have a world like that, then there's not a lot of incentives to playing back and slow and seeing how things turn out. In a world with health where it takes decades to see the changes and what happens to people, you have a really tough situation. And there's so many variables as well. Maybe you make genetic edits that seem to make people smarter, but it turns out this guy just started exercising, or he made more money, so he's able to go back to school, or all of these different things that you can't really hold true. You can't hold them consistent. Well, how do you measure and figure out what works? We're living in a time now where a single human could wipe out all of us. It's been the subject of some books in the past, some pretty interesting ones. For the Da Vinci Code guy wrote a pretty good one. But yeah, I mean, you can create killer strains in your basement with a typical computer and a little bit of extra lab setup. But it's something that high schoolers now can deal with CRISPR technology and create genetic edits. If they're creating gene drives, then we have something really interesting. And these mistakes could be fatal to our entire population. Now, there's definitely major pros, because if we're able to get rid of some of these diseases, that can be incredibly transformational for humanity, reducing suffering and making us all more, ideally we'd all realize we're part of the same species, as opposed to having different countries and different races and religions and all of that. But either way, it's something that should be very positive. Now, that said, right now CRISPR technology is going through a little bit of a hiccup. They found out that when using the CRISPR-Cas9 system to make genetic edits, that there are unintended consequences. So for instance, when you throw a rock into a pond, there's ripples that come out from that. That's kind of like what's happening with CRISPR. They're making cuts, but then they're finding that, like pulling on a string, these DNA sequences are breaking in other areas, which can lead to problems, can lead to cancer, can lead to other things. Realistically, they'll figure this out. And maybe it's not CRISPR-Cas9, maybe it's a different type of enzyme or protein that they're using to create these genetic edits. But just for now, at least, there are some potential problems. But if you have cancer or some other incurable disease, then fuck it, why not? If this can save your life, then I'm certainly going to try it. The last major con I see of the biotech movement and of where we're headed in the biotech space is people forgetting about the fundamentals. So if I think so guys, I think I'm going to live to be 153. I'm saying that right now. I think it's doable based off of the standards where we're at currently in technology, and the fact that I have 100 years or so for the technology to speed up. If we get to the point where we're adding life to humanity at the speed of more than 1 year per year, then we get to what's called longevity escape velocity. But either way, thinking about something and thinking the future is the solution, or there's a magic pill or bullet or something, that's never a good system. So people forget about the importance of diet and nutrition, exercise. They look for a miracle solution. Well, if you're in that boat and it turns out that we are getting better with our technology and we're getting better with increasing human life, but that it takes a while for us to get to that sufficiently advanced state to be able to repair you, well, you might have freaking died already. So you don't want to get hit by a car and you don't want to get hit by your health. Both of those can be majorly detrimental to your efforts to live longer and have a better, healthier, more successful life. Now, predictions. Everybody likes predictions, so let's talk predictions. And I like to throw some timelines on predictions because most people shy away from these. Now, the nature of predictions is it's not necessarily going to be right. In almost every conceivable way, predictions will be wrong, but they're designed to make people think a little bit about the implications and about what that means. And holy shit, I never realized that was possible. I just interviewed Thomas Frey, Google's #1 futurist, and he had a saying something to the effect of, people walk into the future looking backwards. And it's true, because we only know history. We're thinking about what's happened in the past, and that influences how we think about the future, which is an ass-backwards way of doing it. Notice the pun. But anyways, so predictions. I would say within 10 years, we're going to have elites having access to meaningful genetic enhancements. So adding years to your life, reducing your age, improving your fitness, improving health, sexual performance, improving your brain, etc. These types of things. Now, they don't necessarily have to be huge. Let's say we improve someone 1 to a couple percent. They made that one Jason Bourne. They made the spin-off movie when Matt Damon decided he didn't want to do another movie, but they basically were giving these CIA assassins little pills to make them 1 or 2% smarter and 1 or 2% faster than everyone else. And those small percentage differences are enormous. That's all that you get in blackjack from counting cards is a 1 or 2% improvement. And yet you're able to make a fortune by just being able to be a little bit better than average. And the same will be true of this. So it's 10 years having some meaningful edits, not just for curing diseases, but also for self-enhancement. As this happens, governments are going to try to stop the spread of enhancements and edits because as you have, they're going to try to stop the spread while also taking advantage of it themselves, which is really corrupt and really backwards. But I think we can all recognize that most governmental officials want to have power, and they also want to make sure that they're preventing bad things from happening. Both of those not so controversial, but because of that and because of governments trying to block this, it's going to be a black market type thing initially, at least. So we all know people that do, or we may not all know people, but if you look online, you'll find some people doing some really interesting things, injecting stem cells into their brain, into their butts, into whatever. Things that seem fringe will start to become more and more mainstream, but initially, at least, the areas where this is most successful will be the places that have the least regulation, places like Singapore, places like China, places where they already have the frameworks in place to deal with exponential technologies. In the US, healthcare is completely broken. We're not going to talk about the healthcare in the US right now, but there's just so much regulation that I don't see the US leading the way when it comes to a biotech type world or society. I think that this is going to be one of the major technologies of this, not of this decade, of this century. And I think the fact that the US is typically a little bit too Christian about these things is going to create problems where the US may fall behind other countries purely due to the fact of religious or moral type implications of changing what it means to be human. And that's controversial. And you know what? The future is controversial because that's what reality is. Within see a divergence between human species of different types of people. So we'll have some that enhance themselves. We'll have some that don't enhance themselves. We'll have, just with what we have today, we have people that wear funny things in their ears, rings, gauges, tattoos, spiked hair, colored hair, Botox, fake boobs, fake whatever, steroids, all of this, you name it. We have that now when it's purely cosmetic. When we can go to a much more extreme world and much more extreme changes, this will be something that will become much more extreme in how we look and how we feel and how we act and how we express ourselves. Maybe I want to be even more monkey than I am now. I've got some pretty hairy arms. Well, maybe I want a tail. We might not be at the tail stage in 30 years, but we could be at the stage where we do have other types of enhancements. We're moving more towards being animal, being alien, glowing in the dark, you name it. There's some really, really interesting implications coming in the next 30 or so years would be my prediction, just looking at how these exponential technologies with AI, with genetic editing, and with what we're learning about the human biome and genome, it'll make it pretty interesting, especially as genetic testing costs come down. So this becomes something that's more ubiquitous. You might be doing this every year when you're going to your doctor checkup, etc. It'll be a pretty interesting world. Let's see, is there anything else that we need to talk about when it comes to biotech? Well, let's look and see if we have any listener questions right now. So the live streams, they're pretty new. We've just started doing these recently, so we don't have a ton of people yet on each live stream. But if you're enjoying this, make sure that you do hit the subscribe button. You'll find that, YouTube, you don't really need my help. So hit the subscribe button, share this around with others. It doesn't look like we have anybody it doesn't look like we have anybody in the chat. We've got a few people watching right now. So hopefully if you've watched this, if you've enjoyed it, you subscribe, you share it with friends. If you've got any questions, now is the time for those, and we can answer any thoughts, questions, etc. that you guys have on the exponential future as we start to deal with and change genes via all sorts of editing and looking at how all of this plays into a new, different, and hopefully vastly better world. If you got anything, go for it, and if you don't, then we will start to wrap this up. So Kenshin says, it's pretty interesting, but it looks like a scary picture ahead of us. It could open up a nasty Pandora's box. Legal, security in general. I would say yes and no. I think you need to think about it in terms of positivity, negativity, and the human condition. So Kevin Kelly has a saying that humanity's 51% good and 49% bad, and I pretty much agree with that. We move forward every single year, and humanity becomes 1 to 2% better. It's just the fringes, the slight differences, but that alone has left us on a curve that is becoming exponentially better. If you look at Steven Pinkert's book, I don't know what the book's called, we're definitely improving as a species, quality of life, the world, etc. But we do have major problems. So power and self-expression, so the ability to control and have what we want, a lot of this is, I mean, it's due to people not having something in their life. They're missing something, so they feel the need to have power. They feel the need to have money. They feel the need to have the fancy cars. And a lot of that's due to marketing, to be honest. Marketing is designed to make you feel like shit, so you have to buy something. We've talked about that a bit in the past, but what I would like to see, what I'm skeptical that we will see, but what I would like to see is as we start self-enhancing and becoming different as humans and as different species, I would like to see people starting to understand what their inherent problems are so that they're better able to be a more well-rounded person. The problem, though, I don't see this happening in society right now. I see society, at least a lot of society, going the opposite direction, excuse me. So what I see is people becoming more and more focused on themselves. There's a joke I heard on a podcast, but you know how Snapchat made those little Snapchat spectacles? A, that's kind of funny, but B, they did terrible. And the reason they did terrible is because if you look at the next generation, this is the narcissistic generation. And your glasses can't take a selfie, so we're not going to buy something that can't take a selfie. And you see this more and more with Instagram, with social media, etc. People are really focused on themselves, showing how their life is, the material success they've had. There's so much of, look at me and I'm incredible. And while that might make you feel good in the short term, it actually kind of makes you and everyone else feel like shit. And the problem is, as we get into a world where people are genetically enhanced and quite literally better than other people, they're smarter, they're faster, they're sexier, they're all of these things that you would typically define as better, they might not be morally better. And if that's the case, what happens when you have a world of genetically superior, morally inferior, or possibly morally inferior humans? Does that lead to slavery? Does that lead to war? Does that lead to jealousy? What does it lead to? I'm sure it leads to something. I'm sure we're not going to figure out that something now, because these are pretty black swan type events, but it leads to at least the situation where we have to discuss before we move into this what humanity is going to look like in the next 5, 10, 20 years. And do these types of changes make sense? From a regulatory perspective, you can't really hold back stuff like this. If you told me that my wife is going to die from cancer, my son isn't going to be born, I'm going to have a rare genetic defect, I don't care if it's illegal. I'm going to go get a goddamn genetic edit done. Screw what the government says. Screw what the laws say. This is about you and your ability to be yourself and live your life. So people don't really care, which when it's a situation like that, government regulation always fails. And this is definitely one of those situations. So that would be what I would add. Do we have any other questions? Anybody else on the program that has something interesting they want to say or an interesting topic they want to dive into? Take a quick coffee break here. No. Okay, so it looks like that's pretty much everything that we got right now. Again, if you guys like this and you want an even deeper dive, go to fringe.fm/YouTube. You can find our roundtable chat there. We had Aubrey de Grey. He's the incredibly awesome guy from TED with a ridiculously long beard. He thinks there's people alive now that'll live to 1,000. We had Mike Selden. He's one of the leading cutting edge guys focused on clean meat and manufacturing. I mean, they're growing tuna in vats. And we had Jenny Rourke. She's one of the original investors in one of the CRISPR folks. She's focused on biotech and is a venture capitalist that has some really, really interesting perspectives. Go check that out. Subscribe here on YouTube. Hit that subscribe button. Share this out with friends if you find this interesting, if you find it relevant, if you think not enough people are thinking about these type of topics. I would greatly appreciate it if you do that. And if you like this but want to get it delivered directly to your phone instead, fringe.fm/YouTube/Stitcher/Android. Any of those will take you to your respective podcasting platforms so that you're able to subscribe to our Fringe FM podcast. Every Monday and Friday, I have world leaders in the fields of AI, genetics, quantum computing, space, robotics, you name it. If they're doing interesting things that will change the world for the better, the worse, and deal with really major problems, then we're having those type of folks on. It's super high level. We're dealing with really interesting things, and it's something that all of us could really benefit from. I like to say you can do 10x the results but you don't have to do 10x the effort if you think about the right types of problems. These are those problems. These are people that are dealing with really, really big, hard problems, and they're making really, really big impact because of it. Hope this has been fun. Thanks again. I'm your host, Matt Ward, signing off. Until next time, cheers.